Here we go, polyatomic ions, the last topic of this chapter. So far, all the ions we have been talking about are ions formed through the transfer of electrons between individual atoms. An atom either loses or gains electrons and becomes positively or negatively charged. We call those kind of ions, we call them monoatomic ions. Well, there's another kind of ions. These ions are formed from a group of atoms. This group of atoms always stay together. Together, they either lose or gain some electrons, carry a certain amount of charges. We call them polyatomic ion. Those group of atoms within the polyatomic ion are joined together through covalent bond, which is the topic of next chapter. Some examples of compounds containing polyatomic ions. Sodium hydroxide, we have sodium ion, which is a monoatomic ion, and we have a hydroxide ion, which is a polyatomic ion. There are two atoms, one oxygen, one hydrogen within the ion. The hydrogen and oxygen are connected by covalent bond. Magnesium nitrate, we have a magnesium 2+ charge. Nitrate carries one negative charge. That's why you need two nitrate to balance out the two positive charges for magnesium. Okay, so now for polyatomic ion, if you have more than one, you have to put the ion in parentheses and then use a subscript to indicate the number of the polyatomic ion. Next one, ammonium sulfate. Both the positive and the negative ions are polyatomic ion. The positive ion is an ammonium ion, and the negative ion is a sulfate ion. Sulfate ion has 5 atoms in it, 1 sulfur, 4 oxygen. Because sulfate ion carries 2 minus, ammonium ion carries 1 plus, so you need 2 ammonium ions to combine with 1 sulfate ion. One more time, if you have more than one of the same kind of polyatomic ion in the compound, you put the ion in parentheses and use subscripts to indicate the number. If there's only one of such polyatomic ion, you do not put it in parentheses. This table shows us the most common polyatomic ions that we should memorize for this class. You must memorize them, their formulas, their charges. If you don't, not only you will lose the points on the questions that is asking you for these ions, but there will be tons of questions in the future you will not be able to answer if you don't know the charges and formulas of these ions. So try to memorize them as soon as possible. It may sound like a challenging job to memorize all of this. However, there are actual patterns. So let's go through this. Hopefully, it can help you to memorize them. First of all, if you go through the formula of this list, you will see right away, actually, almost all of these polyatomic ions are negatively charged, except 2. One is ammonium ion, one is hydronium ion. These are the only 2 positively charged polyatomic ions. As a matter of fact, ammonium is the only one that will appear in the compound. Hydronium ion only exists in water solution. Now let's move on to negatively charged ions. Among them, almost all of them ends with ate, ATE, nitrate, sulfate, phosphate, carbonate, okay? Almost all of them ends with ATE, but 2. One is cyanide, one is hydroxide. Both end with IDE. Again, IDE means negatively charged. All right, now let's look at the ATE ions. There are a few pairs of ions that they differ by one hydrogen. We have a sulfate and hydrogen sulfate, which is also called bisulfate. We have phosphate and hydrogen phosphate. We have hydrogen phosphate and dihydrogen phosphate. We have carbonate and bicarbonate or hydrogen carbonate. They differ by one hydrogen. And the one that has an extra hydrogen, that ion in the pair, always carries one less negative charge. So sulfate, the charge is 2 negative. Hydrogen sulfate is 1 negative. Phosphate 3 negative. Hydrogen phosphate 2 negative. Hydrogen phosphate 2 negative. Dihydrogen phosphate 1 negative. So the one with one extra hydrogen always carries one less negative charge. Hopefully what we summarized here can help you to memorize them faster. Now let me make one thing clear. These are not all the polyatomic ions. There are many other polyatomic ions, and they will not end with ATE or IDE. Okay, so again, for the ones we need to focus on in this class, here is the pattern which is summarized. Generalizations, well, actually we have went through all of this. Let's go through them one more time. Most of the polyatomic ions have a negative charge, we know that. The charge varies from -1 to -3. There are, however, two positive ions, hydronium and ammonium, and their names end with IUM. We did that, we summarized that. Two of the negatively charged ions, hydroxide and cyanide, have names ending with IDE, all right? The rest, ATE. We did that, we summarized that. A number of pairs of ions exist wherein one member of the pair differs from the other by having a hydrogen atom. All right. In such pairs, the charge on the ion that contains hydrogen is always one less negative than that on the other ion. We did all three of them. Now let's talk about the formulas and names of any compound with polyatomic ions. Nothing has changed. All the rules we learned earlier apply to polyatomic ions. Just treat the polyatomic ion as one ion. So they're determined in the same way as those for ionic compounds that contain monatomic ions. There's no difference. To come up with the formula, the positive and the negative charges present must add to 0. Okay? Sodium and hydroxide, the formula will be sodium hydroxide, magnesium and nitrate. It needs to be 2 nitrate ions to balance the magnesium ion. And you need 2 ammonium ions to balance out the 2 negative from sulfate. Naming: calcium sulfate. Okay, we know that. Ammonium sulfate. Again, you do not need to tell other people there are two ammonium ions, because ammonium always carries 1 plus, sulfate always 2 minus. Therefore, you always have to have 2 ammonium ions to balance out the sulfate. When you say ammonium sulfate, everyone knows you have 2 ammonium ions in there. You don't have to specify that. Oh, this one is called copper sulfate. Suddenly we put a Roman numeral here. Do we still remember that? You will need a Roman numeral in parentheses when the metal in the ionic compound could carry variable charges. We covered that before. Copper, in this case, carries a 2+ charge. How do you know that? You look at sulfate. You memorized sulfate is SO4 2 negative. You memorized that. If sulfate is 2 negative, copper must be 2+ in this case. So copper 2 sulfate. Exercise. Which of the following compounds is named incorrectly? Potassium nitrate, no doubt. Titanium 4 sulfate. Sulfate is 2 negative. We just talked about that. Sulfate is 2 negative. If sulfate is 2 negative, titanium must be 2+. So this is not right. It should be Roman numeral 2. Tin hydroxide, tin 4 hydroxide. Well, hydroxide is 1 negative. We have 4 of those. That's 4 negative. Tin must be 4+, and tin is one of those metals that may carry variable charges. So you do need a Roman numeral. So this is correct. Calcium chromate. Okay, we didn't cover chromate ions in the table, so don't worry about this one. That's the answer. The correct name is titanium 2 sulfate.